Hello, welcome to our channel. In this video, we will look at some examples of solving quadratic equations by completing squares. So here is the method of solving quadratic equations by completing squares. Basically, first we want to write the given equation ax squared plus bx plus c equals 0 in this form. And expression squared equals constant. And that expression is usually linear. And then we can just take the square root of both sides. That will give us some linear expression equals square root of that constant, which is another constant. So let's take a look at some examples to see what we are trying to say here. All right, so here we want to solve x squared plus 49 equals 0. Now this one is quite straightforward because we can just subtract 49 from both sides. That would give us x squared equals 49. So it is already in this format now. Some expression square equals constant. So that expression is just x. The next step, we can just take square root of both sides. On this side, you will have just x left. And on this side, we have square root of negative 49. And whenever we take square root, we get plus or minus, because both positive and negative squared will give us the original value. So we get x equals plus or minus square root of negative 49. Now we can simplify this little further, because whenever we have square root of negative number, we get an imaginary number. So it will look like square root of 49i, because if you recall our discussion about imaginary numbers, whenever we have square root of a negative number like this one, this we can write as square root of negative 1 times 49. And then we can apply square root to both of these, negative 1 and 49. So we get square root of negative 1 and square root of 49. And this square root of negative 1, we simply denote this by I, an imaginary number. So that's how we got this I over here. But this square root of 49 is simply 7. So we get plus or minus 7i. So we have two solutions, x equals 7i and x equals negative 7i. Let's look at the next example now. So here we want to solve x squared minus 3x equals negative 18 by completing square. So the first step is to identify a, b, c. For that, we want to write in this format ax squared plus bx plus c. So it will look like x squared minus 3x plus 18 equals 0 if you add 18 to both sides. And from here, we see that a is 1, the coefficient of x squared, b is negative 3, the coefficient of x, and c is 18. So once we have a, b, c, then we can use this formula to write in the complete square form. So that will give us a in the front, which is 1 in this case. And we have x plus b by 2a squared. So we will put that here. X plus b is negative 3. Negative 3 by 2 times 1. So negative 3 by 2a. Next we have plus c. C is 18. And then we have minus p squared by 4a. p squared would be negative p squared by 4a, 4 times 1. And equals 0 on the right side. So we have it set up here. We want to simplify this next. We have x minus 3 by 2 squared over here plus 18. Then here we get 9 by 4, minus 9 by 4 equals 0. We can combine these two. So we get x minus 3 by 2 squared. So 18 can be written as 72 over 4. So that we have the same denominator, 4 and 4. And then we can just combine the top parts. So 72 minus 9 is 63. We get 63 over 4 equals 0. We are almost there. We want to write in this format. So we want to move the constant to the other side. So that will give us x minus 3 by 2 squared. So if you subtract 63 by 4 from both sides, you get negative 63 by 4 over here. Now the last step is to take square root of both sides. So I'm going to do that over here. So on the left side, we just get x minus 3 by 2 equals, on the right side, we have plus or minus square root of negative 63 by 4. So that means if we add 3 by 2 to both sides, we get x equals 3 by 2 plus or minus square root of negative 63 by 4. Now here we have square root of negative number. So we get an imaginary number over there. So it will become 3 by 2 plus or minus square root of 63 by 4 I. So whenever we are doing square root of negative number, we get an imaginary number. And we can go one last step. So 3 by 2 plus or minus. Since square root of 4 is 2, we can write this as square root of 63 by 2i. These are the solutions. 3 by 2 plus square root of 63 by 2i, and 3 by 2 minus square root of 63 over 2i. We are done with this example. And next we have 2x squared minus 5x equals 3. Again, we want to complete square. Now in the previous example, we moved that constant on this side to the left so that we could have ax squared plus bx plus c form and then completed square. Or you can just leave that 3 as it is over here and just try to complete square on this side. So let's try to do that. So if you just look at this side, we have a equals 2, the coefficient of x squared, b equals negative 5, and c is 0, the constant. So we don't have any constant over here. So c is 0. So we're just looking at the left side. So using these numbers, we can complete square with this formula by applying this formula. So we have a in the front, which is 2. And then we have x plus b by 2a squared. So b is negative 5 by 2a, 2 times 2 squared, plus c is 0, minus b squared by 4a, b is negative 5 squared by 4 times 2 equals 3 on the right side. So we are not doing anything to that 3. We need to simplify this next. 2 times x minus 5 by 4 minus, so we have 25 by 8 over here, equals 3. Our goal is to write the equation in this format. So we want to move this constant to the right. Basically, you want to add 25 by 8 to both sides. So that will give us 3 plus 25 by 8. But 3 we can write as 24 by 8. So this will become 49 by 8. When you combine these two, 3 is 24 by 8. So 24 plus 25 is 49 by 8. Okay, now the last step. We don't want that 2 over here in the front. So you can divide both sides by 2. Then that will give us x minus 5 by 4 squared equals 1/2 times 49 by 8, which is 49 by 16. So this is exactly in this format. Now we can take square root of both sides. On the left, we get x minus 5 by 4 equals plus or minus square root of 49 by 16. So 49, square root of 49 by 16 is simply 7 by 4. Square root of 49 is 7. Square root of 16 is 4. So we get x equals, now we can add 5 by 4 to both sides. So we get 5 by 4 plus or minus 7 by 4. So when we take plus, we have 5 plus 7 by 4, which is 12 by 4, which is 3. And when we take minus, we have 5 minus 7 by 4, which is negative 2 by 4, which is negative 1/2. These are the solutions, 3 and -1/2. Here we have the next example. We want to solve 12x squared plus 6x equals 0. Again, by using the method of completing squares. So first we identify a, b, and c so that we can complete square on 12x squared plus 6x. So here a is the coefficient of x squared, which is 12, and b is 6, the coefficient of x, which is 6, and c would be 0 because we don't have any constant term here. So once you identify a, b, and c, then we can apply this formula to complete square. That will give us a in the front. So we have 12, and then we have x plus b by 2a squared. So x plus b is 6 by 2a, 2 times 12, plus c, c is 0, minus b squared by 4a, 6 squared over 4 times 12, and equals 0 on the right side. So next we want to simplify this setup here. So we get 6 over 2 times 12, which is 6 over 24, which is 1/4, plus, but we have minus over here, so it will come out to be minus. So 36 over 48, 36 by 48. So this 36 by 48, we can actually reduce. So we can divide top and bottom by 12. So it will be 3 by 4. And we get equals 0. Next, we can move that 3 by 4 to the other side because our goal is to have this format. Some expression squared equals constant. So x plus 1 by 4 squared equals 3 by 4. And next we can divide both sides by 12 or multiply both sides by 1 by 12. So that will give us x plus 1 by 4 squared equals 1 by 12 times 3 by 4, but 1 by 12 times 3 by 4 is simply 1 by 16. And the last step, we just take the square root of both sides. So we get x plus 1 by 4 equals plus or minus square root of 1 by 16. Now, square root of 1 by 16 is simply 1 by 4. So that will give us plus or minus 1 by 4. So the next we can just subtract 1/4 from both sides. So x will become negative 1/4 plus or minus 1 by 4. We can separate this plus or minus. When you take plus, we have negative 1/4 plus 1/4, which is 0. And when you take minus, you have negative 1/4 minus 1/4. So let me write all that out here. So when you take plus, we have negative 1/4 plus 1/4. And when you write minus, you have negative 1/4 minus 1/4. So over here, negative 1/4 plus 1/4 is 0. Negative 1/4 minus 1/4 will be negative 2/4, which is negative 1/2. We have these two as solutions to this equation. Let's look at the next example now. X squared equals 12 plus 5x. The first step, we want to move that 5x to the left. So we have x squared minus 5x equals 12, because we want to have just constant on the right side at the end. So now we will look at this one and try to complete square. So here a is 1, the coefficient of x squared, b is negative 5, the coefficient of x, and we don't have any constant term on the left side, so c is 0. Then we can apply this formula to complete square. So we get a, which is 1, times x plus b by 2a squared. So x plus b is negative 5 by 2a, 2 times 1, plus c is 0, minus b square is negative 5 square over 4a, 4 times 1, equals 12 on the right side. We need to keep that as it is. Let's simplify this equation a little further. We have x minus 5 by 2 squared over here. And then here we get minus 25 by 4 equals 12. Our goal is to write in this format over here. So we want to have all the constants on the right side. So let's add 25 by 4 to both sides. So that will give us x minus 5 by 2 squared equals 25 by 4 plus 12. We can combine this 25 by 4 plus 12 because 12 is simply 48 by 4. So if you combine these two, we get x minus 5 by 2 square on the left. And on the right, we have 25 plus 48 by 4. So 25 plus 48 is 73. We get 73 by 5 on the right side. Now we just take the square root of both sides. When you do that, we are left with x minus 5 by 2 on the left. And on the right side, we have plus or minus square root of 73 by 4. And square root of 4 is 2. So we can write this as plus or minus square root of 73 over 2. And then we can add 5 by 2 to both sides. So we get x equals 5 by 2 plus or minus square root of 73 over 2. So we have these two solutions. If you want to write them separately, we have 5 by 2 plus square root of 73 over 2 and 5 by 2 minus square root of 73 over 2. So these are two solutions. All right, so this is all we have put together in this video. Thank you for watching, and please subscribe to our channel if you haven't already.